This video we're going to talk about one-sided limits. So let's look at this piecewise function f of x equals x minus 1 if x less than 0 and x plus 2 if x greater than or equal to 0. Now the graph of the function is given, and usually you're asked to find if the limit exists at the number you see there, which is 0. Now by looking at the function, I need to check what is the limit as x approaches 0. As we said before, if you have the graph, you can check as x approaches 0 from the left side. It means you're taking these points and check it's getting closer to which point. Even if it's a hole, but still it's approaching that hole that has a y value equals -1. So the limit as x approaches 0 from the left side is -1. Now, when we're talking about the right side, I need to check these points that are getting really close to the value 2. So the limit as x approaches 0 from the right side, it's gonna be 2. In this case, the two limits are not equal from the right side and the left side of 0. Then we say the limit does not exist. If I want to write this, I will write this. Limit as x approaches 0 minus, and 0 minus, it means left of 0, of the function f of x is limit as x approaches, again, 0 minus, it means from the left side, so we're talking about the negative part. It means I'm talking about the first piece of the function, so of x minus 1. Then we can replace 0 there. When I replace now, no need to replace 0 minus, you can just replace 0, so 0 minus 1, and the answer is -1. And then I check the other one, limit as x approaches 0 plus of the function f of x. It's gonna be limit as x approaches 0 plus, it means we're talking about the positive part, which is the second piece of the function, x plus 2. We replace 0, and our answer will be 2. Since these two limits are not equal, we say the limit as x approaches 0 only of the function f of x does not exist. Now, theorem, the limit at the value a, so limit as x approaches a of the function is equal to L, so it exists and it's equal to a number if and only if the limit from the left side and from the right side of a are equal to the same number. Okay, so for the limit to exist, we need to have the limit from the left side and from the right side are equal. Let's check this example. So here, for sure, you'll be asked about 0. So let me call this A, this is part B. I check limit as x approaches 0 minus. 0 minus, it means from the left side. So we're talking about the first piece. 0 minus, it's the negative part. So we're talking about the first one of the function. So we replace the first piece, minus x, and then we just replace 0 there. No need to write 0 minus, which is 0. Then I do it from the right side. It means we're talking about the positive part, so we take the second piece and also we replace only 0. The answer is 0. Since these two are equal, now I can conclude that the limit as x approaches 0, now we don't care from the left or the right, of the function f of x is equal to 0, to the same number we got here and there. Now, for g, let's check. Limit as x approaches 0 minus of the function g of x is equal to limit as x approaches 0 minus of -2. And we say limit of a constant number, it stays the same, so it's equal to -2. Now limit as x approaches 0 plus of g of x is limit as x approaches 0 plus. We're talking about the positive part So the second piece, which is 2. Now I look at these two, they are not equal. In this case, we say limit as x approaches 0 of g of x does not exist. Now, let's apply the same idea here. You're asked to evaluate the following limits. Now, only we care about 2 minus or 2 plus if we have something in the denominator or maybe inside the radical. So let's check for this one. Alright. So in the numerator we don't care. So once I substitute, I don't need to write limit. So 2 plus 2 on top. We don't care if it's 2 minus or 2 plus. But in the denominator, actually, it's very important to understand that the 2 minus will make a difference, or if it's 2 plus, also it will make a difference. 2 plus 2 on top is just 4, but 2 minus 2 down, it's gonna be 0. But is it 0 plus or 0 minus? Now, when we say 4 over 0, later on you're gonna see that this answer, whenever you divide a number, constant number, by 0, the answer is gonna be infinity, either plus or minus infinity, and this will give us asymptotes. Okay, now 4 over 0, now is it 0 plus or 0 minus? 2 minus, 2 minus, 2 minus, I need to know what is it. So as 2 minus, what is that number? It's like 1.9999, maybe more. So when I subtract 2 minus 1.9999, it's gonna be like 0.000001, which is bigger than 0. That's why we write it's 0 plus, as if we are on the right side of 0. Now in this case, 4 over 0 plus, this will give us infinity, and we need to check the sign of the infinity. Is it positive infinity or negative infinity? I check the number on top, it's a positive, and 0 plus is positive, so our answer will be plus infinity. Now when I say plus infinity, it means the limit here does not exist, and later on we're gonna talk about vertical asymptotes. So this will give me a vertical asymptote. So from the limit here we can tell that we have a vertical asymptote which is x equals 2. It's a vertical line, x equals 2, where the graph will not touch this line. I'm gonna make another video about asymptotes. Now let's check the one here. We replace, instead of x2 on top, we don't care if it's plus or minus, but the one down, actually we care. 2 plus, it means like 2.00001. When I do 2 minus 2.0001, my answer will be like 0. But imagine you're doing 2 minus 2.00001, it's gonna be like minus 0.0001, as if you are on the left side of 0, so it's 0 minus. Now, positive over negative, it's gonna be negative. 4 divided by 0, which is number divided by 0, is just infinity. Whenever you don't get a number, you get infinity, we say the limit does not exist. And also in this case, we say we have vertical asymptote at x equals 2. Let's check the last example. Now, I said whenever we have radical, we need to care about the plus or minus. So for the one down, I will write minus 2 cubed plus 1. So as long as the answer, when I substitute the number we have, it's not giving me 0, then no need to write plus or minus. However, in the numerator or denominator, where you replace the number you have and you get an answer that is 0. You need to know if it's 0 plus or 0 minus. Now I will write minus 2 plus 2 on top. So for the denominator, we're gonna get minus 8 plus 1, which is only negative 7. Now let's understand what is the meaning of minus 2 plus. On the number line, if this is the minus 2, this is the minus 1. So minus 2 plus, it means I'm here on the right side of negative 2. And this number is like minus 1.9999. So on top, we're gonna get minus 1.999 plus 2. It's almost 0.00001 maybe, right? So which is still positive. So we get like radical of 0 plus. If it was radical of 0 minus, as if you are saying radical of minus 0.0001, and in this case we cannot have negative under the square root, so this will be like undefined. However, for this one it's defined, so radical of 0 plus is just 0, because radical of 0 is 0, and the plus here, it tells us if the radical is defined, it has an answer or no, over negative 7, and in this case we get an answer that is 0. Now whenever we have limit as x approaches a number, it's equal to a number. In this case we don't have any asymptote, alright?